Good morning, student. Today I am going to start application of derivative rate and measures. What is rate and measures? It is a part of application of derivative. Suppose y equals to fx is a function of x. Then small change of x is we can write del x, and small change of y we can write del y. This is del x is small change of x and del y is small change of y. Then change of x in respect of y, change of a small change of x with respect to y is del x by del y. So actual change of rate is limit del x tends to 0, del x by del y equals to dy by dx. That is the formula. Actual change of x with respect to y is dy by dx. That is in this formula we can get rate and measure sums. Let us do few sums like this from this chapter. Sum number 1. The volume of a spherical balloon. Volume of spherical balloon. Balloon is increasing at a rate at a rate 24 centimeter per second. Volume is centimeter cube per second. Find the rate of change of surface. Find rate of change of surface area when radii is 6. Actually, a spherical balloon, suppose this is a spherical balloon, it will increase. The increase means that it is increasing. The rate of increasing is increasing at volume of a spherical balloon. Initially, then it is increasing at a rate that is dV by dt. dV by dt is 24 centimeter cube per second. Rate of change of its volume is 24 centimeter cube per second given. So volume, what the formula volume of a spherical balloon? 4 by 3 pi r cube. And we have to find the rate of change of surface area. Surface area of the balloon is 4 pi r square. We have to find surface area, suppose S. S is 4 pi r square. To find ds by dt, what will be ds by dt? Find the rate of change of surface area when r equals to 6. You have to find this. So first of all, this is given volume dv by dt equals to 4 by 3 pi 3 r square dr by dt. So dv by dt is 24. So 24 equals to 3 cancel 4 pi r square dr by dt. So 24 by 4 pi r square equals to dr by dt. That is 6 by pi r square is dr by dt. We got dr by dt is 4 pi r square dr by dt. 6 pi r square dr by dt we have to We need it. Now we have to find ds by dt. What is ds by dt? ds by dt equals to 4 pi r square means d2r dr by dt. dr by dt value we know. So 8 pi r. dr by dt value is 6 by pi r square. That is pi cancel. This and this cancel. 48 by r. r is 6. That is 8. So the rate of change ds by dt is 8 centimeter square per second. Therefore, rate of change of the surface area is 8 centimeter square per second. Next, sum number 2. The volume of a cube is increasing. Volume of cube increasing at constant rate. Prove that the increasing of its volume. Prove that increasing of its volume, increasing of its surface area varies inversely as the length of the cube. Varies inversely length of an edge of the cube. Actually, volume of increasing at a constant rate, that is given dv by dt equals to constant. It is given. Suppose constant, where k is constant, it is given. dv by dt is given. You have to find surface area, that is ds by dt inversely length of its edge of the cube. Suppose edge of the cube is edge of cube equals to x centimeter. And that you have to find 1 by x. You have to find this surface area inversely proportional to its edge of the cube. Edge of the cube is x centimeter. Suppose. So here given up we know volume of a cube v is x cube. Our surface area is equals to cube 6x square. We know it. You have to know the formula. Volume of the cube is this. Now dv by dt 3x square dx by dt. Now dv by dt value you know, it is given k. Suppose k equals to 3x square dx by dt. So k over 3x square equals to dx by dt. Now we have to prove that surface area inversely proportional to the side of the cube. We have to differentiate it. That is ds by dt equals to 12x. Differentiating dx by dt. That is 12x. dx by dt value is put it here. K over 3x square. That is x cancel, x square cancel. That is 3 4s are 12. That is 4k by x. So ds by dt is 4k. Where is 4k is constant. Therefore ds by dt varies as 1 by x. That's all. We have to prove this. We got it. So surface area of the cube inversely proportional to its edge of the cube. Next, sum number 3. Sum number 3. A particle moves along a curve. A particle moves along a curve y equals to 2/3 x cube. Y equals to 2/3 x cube plus 1. Find the point. Find the point on the curve at which y coordinate is changing. Y coordinate changing twice as fast as x coordinate. So what is question? A particle moves along a curve find the point on the curve. You have to find the point on the curve at which y coordinate, that is dy by dt, twice as dx by dt. You have to find, it is given dy by dt twice, it is given. First you have to given y is this, y equals to 2/3 x cube plus 1. Now differentiate with respect to t. Then dy by dt equals 2/3 into 3x square dx by dt. 3 cancels. Then dx by dt, dy by dt is 2. Dx by dt implies, we know dy by dt value, this is given, equals to 2x square dx by dt. 2 cancel and we can write dx by dt x square minus 1 equals 0. That is x square equals to 1, x equals to plus minus 1. Then putting the value of x is 1, put it here, then we get y equals to 2/3 of x cube plus 1. When x is 1, then y equals to 2/3 plus 1, that is 5/3. When x is 1, then another coordinate is 5/3. And when x is minus 1, then y equals to minus 2/3 plus 1, that is 1/3. So minus 1 and 1/3, that is the coordinate of the coordinate. Find the coordinate or find the point on the curve at which you have to get. There a point is 1 and 5/3 and 1 and 1/3. That is the coordinate of the point. Next sum number 4. X increases at a rate 3 units per second. X increases at a rate 3 units per second. How fast its gradient? How much is gradient of the curve y equals to 5 plus 6x square minus x cube when x equals to minus 2. How fast is gradient? How fast is gradient of the curve? How fast is the gradient of the curve change? How gradient of the curve change? Then you have to find gradient. Suppose dy by dx is the gradient. Here given increase of a rate, x increases at a rate 3 units per x increase at a rate 3 unit is given. X increases at a rate, that is dx by dt equals to 3, it is given. X increases at a rate 3 unit per second. Now equation of the curve y equals to 5 plus 6x square minus x cube. Now we have to find dy by dx. dy by dx equals to 12x minus 3x square dx by dt. dy by dt. So dy by dt here dy by dx is this different in respect to x. So dy by dx is m. dy by dx equals to a. It is gradient. If x increases at a rate 3 unit per, this is gradient. dy by dx is x. So m gradient. So m equals to 12x minus 3x square. Now we have to add dm by dt. dm by dt. Differentiating increase of rate of how fast the gradient of curve changing. That is, this is gradient. dy by dx is gradient. So dm by dt equals to 12 minus 6x into dx by dt. And dx by dt value is 3 given. That is 12 minus 6x into dx by dt value 3 given. That is 36 minus 18x. That is 36 minus 18 into value of x is minus 2. That is 72, changing 72 unit per second. I am telling again, x increases at a rate 3 unit per second. That is dx by dt is given. How fast gradient of the curve? So you have to get dy by dx gradient. We need gradient. That is dy by dx is this. The dy by dx is gradient. The m is this. Now how fast gradient is increasing? That is dm by dt you have to find. dm by dt difference is respect to t. We got, and here x is minus 2. Next sum number 4. Sum number 5. A ladder 5 cm long, a ladder 5 meter long, leaning along a wall, leaning on a wall. The bottom of the ladder is pulled along the ground. From the wall. At a rate 2 meter per second. 2 meter per second. How fast the height of the wall? Question is how fast the height of the wall decreasing when the foot of the ladder ladder 3 meter away from the wall. I'm telling here, suppose this is the wall and this is the ladder. It is 5 meters. Suppose height of the wall is y and this is x, and this is pulled is here like this. Ladder is pulled. This to this is 3 meters still. 3 meter away. The how much will be decreased. Question is, how fast the height of the wall decrease when the foot of the wall ladder 3 meter away from the wall. Foot of the ladder 3 meter away from the wall. How much will this then decrease? You have to find dy by dt is how much. So here, first of all, suppose this is x, this is y. Height of the wall is y, and length of the length from the ladder from the wall is x. So here is x square plus y square equals to 5. That is x square plus y square equals to 5. Root over of x square plus y square is 5. Do Pythagoras. That is x square plus y square is 25. Now differentiating respect to t. 2x dx by dt plus 2y dy by dt equals to 0. Then dy by dt equals to minus x by y dx by dt. You have to find dy by dt. Here dx by dt, that is pulled along the ground wall is 2 meter away. Pulled along the ground or from the wall at a rate 2 meter. That is dx by dt equals to 2 given. Here dx by dt equals to 2 meter per second. Put it here. Dy by dt equals to minus x by y into dx by dt value is 2. Now when dx by dt is 2, when x is 3 meter away, when x is 3 meter away, then what will be y? So 9 plus y square equals to 25, y square is 16, y equals to 4. When x is 3, y is 4, put it here. That is x is 3, y is 4 into 2. That is minus 3 by 2 meter per second. The dy by dt is minus 3 by 2 meter per second. You have to find dy by dt. Therefore, the how fast the height of the wall decrease. Height of the wall, this wall will be to come down, decrease at a rate 3 by 2 meter per second. This decrease means minus. Answer is minus 3 by 2 meter per second. The height of the wall decreased by 3 by 2 meter per second. That is the answer. Please note it down and look through the sums. And if you like please subscribe my channel. Okay, thank you.